Thank you everybody for joining in on today's event, Data Modeling Patterns Every Analyst Should Know with Ergest Xheblati. Ergest, this is your third workshop with the Operational Analytics Club, so we thank you for coming back and we welcome you back anytime you want. Today he's going to talk about data modeling patterns every analyst should know. And if you look at the bottom of your screen, I provided a link to Ergest's previous workshop that I really enjoy, SQL Patterns Everybody Should Know. So with no further ado, Ergest, the floor is yours. Thank you very much.
Thank you, Parker, and thank you to the Operational Analytics Club for hosting me for the third time. I really enjoy doing these, and I really enjoy sharing my knowledge with the world. So this workshop is going to be focusing on some data modeling patterns that I found useful in my career, that I use, and that I am learning to use more and better in better ways. On the agenda today, I'll talk a little bit about who I am. Some of you may already know me. You've attended other events, or we have exchanged some information on the Slack channel for operational analytics. And then for those of you who don't know me, I'll give a brief intro, and we'll then talk about how to model a business process with activities, which is a bit of a different perspective from the traditional modeling techniques. And then how to go from activities to your traditional entities and attributes, and why you should model with activities first. And then we'll do an example where we talk about how to model growth accounting, specifically for SaaS business. So who am I? So for those of you who do not know me, I have a computer science degree, but I did not enjoy being a software engineer. I recently discovered there's other people like this who, they love programming, but they don't like software engineering per se. Hey, there's the world of data for you. So once I stumbled upon the field of data about 15 or so years ago, I was just hooked. I fell in love with the engineering aspect of data, especially with SQL, to the point where, 15 plus years later, I still use it. I still love it. I even wrote a book on SQL. And so, yeah, I discovered that I really enjoy kind of explaining these technical things to sometimes non-technical users in a business, or like teaching these concepts to the community. And so this is why I'm here today to kind of talk about some of the new data modeling patterns that I've discovered more recently. Okay, so with that out of the way, let's get into what I mean by modeling with activities. So a business, as you all know, is made up of different business processes. So we have, for example, customer acquisition, also known as marketing. We have sales. We have, some operations. We have customer success. All of these aspects of the business are made up of processes. And each one of these processes are made up of activities. So the activities are sort of the primitives of these processes. So what are these activities? If you're familiar with knowledge graph lingo, they're similar to RDF triples. So an RDF triple, not quite sure what RDF stands for, like resource data framework or something like that. I may have that completely wrong, but it's basically a subject, predicate, and an object. So a subject is somebody, and then the predicate is the verb, and then the object is what the verb applies to. And so the way to think about this is through this framework of the 7 W's. This is a framework that is introduced in the book Agile Data Warehouse Modeling by Lawrence Core, that I'll have a slide at the end that has some recommendations. So this is one of the books that I recommend because he goes into a lot more detail of how to do this business event model. He calls them business events. I call them activities. Activities can form the conceptual and logical layer of modeling. If you're familiar with modeling lingo, data modeling lingo, it is usually comprised of these three aspects. So we have the conceptual layer, the conceptual model, the logical model, and then finally the physical model. Activities make up the conceptual and the logical layer. So here's an example, right? As I said, these are RDF triples. So for example, visitor views content. You have somebody coming into your website and they view a particular piece of content that you want them to view. Perhaps it could be a white paper, perhaps it could be a demo video, perhaps it's something that they download, like a piece of software or something like that. You might have another activity that's like visitor starts session or visitor submits a marketing form. Now, these may seem to you similar to what events typically look like. So, for example, customer clicked on something or customer opened a page. The difference between events and activities is the level of detail, the granularity, right? So, activities are a little bit more abstract, a little not as detailed as events. We are not talking about events here because events could be anything from, they clicked on this button, they opened this drop down menu, they chose this item from the drop down menu. We don't really care about a lot of those. They don't form an aspect of an activity that we care about. We care about the visitor actually viewing the piece of content that we want them to view. We care about them submitting a form and such, and so kind of qualifying themselves as a potential interested lead. So this is the level of detail that these activities make up. So let's see how these activities work. Why should we model with activities? So traditional modeling patterns that you see in a lot of data warehouses these days is that companies will go from raw data to like a metrics table, like facts and dimensions, or star schema, also known as a star schema. And typically that then gets fed into a BI tool like Looker or Tableau. Same thing, if data science then or machine learning team, they want to build a model, they will go to the raw data, build a feature store, which is basically like a table of signals for whatever they are interested in. They'll build a model and then perhaps feed that model through reverse ETL to a tool like Census. So what are the pros of this method? And this is something that I have seen in my career. This method is very easy to get started, right? So you have data engineering dump all the data from all the different sources in the business into the data warehouse. And you as an analyst that you need to get some report done, it's very easy to just take some raw data, join a bunch of tables, create some metrics, and push them to Looker and Tableau or whatever you need. So in that sense, it's very quick to deliver results. And I've seen this myself, where companies will get started with this and basically say, you know what, we just need to get this thing out of the way. We need to get people using this thing, and it doesn't require a lot of modeling, doesn't require a lot of designing upfront. Well, soon enough, and I've seen this twice so far in my career, soon enough, these events start to get very complex, and the logic gets repeated in multiple places. Numbers no longer match. You have hundreds of thousands of tables in the data warehouse. And these models themselves are very brittle in the sense that if the source data changes, if there's a new column added or a column is renamed or the granularity changes, these models will break very easily. A lot of data analyst time is actually spent fixing models and dealing with changes. So maintenance is really a nightmare. What I'm recommending is that you build an activity layer between the raw data and your final results table. So this activity layer, and we'll look at what these activities actually look like. But this allows you to model the business with data coming in from multiple sources. Then from activities, you can go into entities and attributes, you can create dimensional tables, you can create feature stores, you can do metrics and for BI tools and all of that. And the activities also serve as um, like a data contract between the data team and the engineering team. So if there's a change that happens, for example, to a schema, you only need to fix it in one place. And this goes back to one of my favorite patterns that I use to this day, that I wrote about in my book. And it's called the single responsibility pattern. The idea that all the um, all the responsibility for doing some sort of data cleaning should exist in a single place. You should not have business logic downstream. If that exists downstream, it would be a good idea to move it all the way up to this activities layer. So what this gives you is a logical layer, right? So this forms kind of the conceptual and the logical layer for all the business concepts. It provides, like we said, an interface to raw data. So like a data contract is a lot more robust to change because you make the change in one place, and then everything downstream sort of inherits that change, or you just change the pieces that you actually need to change. It's easier to maintain on the long term. You don't get this mess of tables in the data warehouse, but it is harder to get started or to convert like an existing implementation, um, because it requires a little bit more design. So it's a little bit slower to deliver results. But if you read Lawrence Kor's book, he talks about how to do this in an agile way by delivering kind of value as you go along. As you know, one of the tenets of agile programming is that you want to deliver value quickly. You want to show results quickly. So with activities, you can get there. You can start with a specific process, build it out, and then deliver that, as I have done with growth accounting. So let's look at that. Let's look at a use case. This is the growth accounting aspect of SaaS, so like a SaaS business. What I mean by growth accounting is things like, recurring revenue. So you have like new revenue, you have churn, you have like expansion revenue or contraction revenue, or you have like resurrection when a customer comes back. All of those all of those metrics indicate the health of a business and are sort of used in that way. Okay, so here are the actual activities from our from the project that I mentioned earlier. We're starting with the SaaS business. So on the left side, we have activities that are coming from like a CRM system, like a Salesforce or HubSpot or one of these systems. So we have like a contact signs a contract, or this customer renews a contract, they expand or contract on the contract. I guess the renew shows up twice. That's my bad. They can commit to churning. Basically, they can say, okay, I'm paying for this month, but I want to cancel this contract. So the contract will run till the end of that period and then basically end. But you know ahead of time that they are going to churn. Or a customer resurrects, and by that we mean that the customer had churned before, canceled before, and then they come back after a fixed period of time. Let's say they were away for 3 months. They call you back and they say, "Hey, can we get back on a contract?" And that's you then sign a new contract for that customer. So you can sort of see how this makes up pretty much the kind of the contract. This handles the contract signing side of the business. And then on the accounting system, this is where you have the actual money coming in. So you have customers starting their subscription and beginning to get charged. They, for example, get an overage on their contract, or they order like a one-time support service, or something like that. And then we have an activity that says the customer is active on the subscription, so that we can track existing revenue, right? And then we have when the customer churns, when they cancel, we have customer ends subscription. Well, why am I mentioning all of these things, right? How does this actually lead to modeling, right? When you go and talk to a business person, like a finance person or a salesperson, and you ask them, so how does this work? How do we make money? What is our business model here? And you'll get these sort of like user stories. They're sort of like user stories, right? They're something similar, but they're much more business oriented, right? So it's similar to how you, as a PM, for example, you would go and ask for these user stories for the business. These are the operational kind of user stories, right? That's how you gather the activities. And this is what data looks like. This is actual data from, well, not actual, this is fake data that I generated for my project. Okay, you will notice here, it's a very simple schema, very straightforward, and I'll cover that in the final slide. So there's a row ID, one for each row. There's a customer ID, in which case this would be like the company. Like you would have an ID for the company that started that subscription, and you have the timestamp of when that subscription began. You have kind of a revenue impact. And then you have some features. So this feature JSON field is basically a JSON blob of multiple kind of like metadata that pertain to that specific activity. Now, what are the benefits of this? One of the benefits of this is that these are immutable, right? One of the biggest problems that I've seen with modeling in data warehouses, the traditional way, is when data changes. So you have either slowly changing dimensions, or you have late arriving facts. You have all these things that kind of like take your beautifully designed model and turn it upside down, right? Okay, now we need to add a new column. Well, you have to add the column, you have to repopulate all the data in that column. You have to then like move it perhaps to a new table, or you have to like expand or change the type of a column. A lot of these sort of like data engineering aspect of the modeling can get pretty messy. But with these activities, right, these activities are immutable in this sense that they don't change. We know that on March 17, customers started their subscription. If that number, for example, was wrong, the 5,534, we can insert a new activity that is an adjustment to the specific, to this particular revenue. So when you roll it up later on, the totals actually make sense. I was watching a presentation on how, from 10 years ago, on how immutability changes everything. It's actually called Immutability Changes Everything. And one of the phrases that I kind of remember vividly, and it makes so much sense to me, is accountants don't use erasers. Okay, let that sink in for a little bit. Accountants actually can't use erasers. It's against the law if they manipulate data. So they have to record every little change, right? Okay, yes, this is the amount that I told you before, but now I'm making an adjustment or an amendment to actually show the actual amount. So this is kind of the same idea here. Because this data is immutable, we can store it just once and forget about it, basically. The feature JSON is then used for creating dimensions, and I'll show you how that is done. And the way the activity schema works is you get one table for each of the activities. So you would get like one table for customer signing the contract, a separate table for customer renewing the contract, and so on and so forth. And then if you want, you can union all of these into a single table. Now let's see how these events actually map to metrics. Okay, so I was talking about how the whole purpose behind this is to have these the growth accounting. Growth accounting has these metrics: new recurring revenue, expansion revenue, contraction revenue, and so on and so forth. Well, they map directly one-to-one to these activities. And then if you want to have a calculation on top of these metrics, so you want to combine, new plus expansion plus contraction plus retained, et cetera, it's very easy to do. You just um, aggregate this data and then sum it up and put it in a new model. And I'll give you a link to my repository where you can see how I've actually done this. But this is how it's actually done. So you can see here, this is a select query. So I have a table called customer stream started subscription, right? And I have a customer table here that is kind of like a dimensional table. I'll show you that in an ER diagram in a little bit. But these are the fields that we want. So we want perhaps the customer cohort, the first touch channel, or the last touch channel, depending on how marketing does their attribution, the activity timestamp, and the revenue impact, and the actual activity. And then we can expand this JSON field to pull out the segment and the plan. And this then becomes a cube. I don't know if you're familiar with the concept of a cube. An OLAP cube is basically a multi-dimensional data structure that allows you to store aggregations at each combination of dimensions. So for March 1st, for segment 17, I will have one metric value, like a metric aggregation, and then for let's say segment 16, same date, another row, segment 18, same date, another row, and then for the next day, segment 17. So basically this table contains all the combinations of all the potential segments. Now, the reason why we can do this for our project is because we have a pretty narrow set of dimensions. And if you know what those are ahead of time, you can actually build something like this. But more often than not, you may not know that, so you can sort of leave this step later on. You can set up your BI tool to deal with this step. For our project, we are being very prescriptive, where we tell you exactly what you should be measuring and what dimensions you should be measuring it by. So how do we now go from these activities to entities and attributes? Like, why would you want to do something like that? Well, maybe you want a table that you want to report on, or maybe you want a table that you can join with other tables for some kind of data manipulation later on. So you can take each one of these activities, so that when the customer signs a contract, when they expand or they contract on the contract, and you can have a contract ID, right? The customer ID that actually is part of the feature JSON in each one of these. Actually, no, it's not part of the feature JSON. It's part of the it's just part of the activity schema itself, right? The customer ID is part of the activity schema itself. And then but the plan might actually end up being a separate table. So maybe we have like 5 plans, and we have a plan ID that maps to the plan. So each one of these activities turns into like a date in our table. You can see renewal date, subscription start date, end date, the amount, recurring payment type, service calls, and so on and so forth. So this is how you can go from activities to an entity and an attribute table. So this is kind of the ERD schema, which some of you may be familiar with, right? So we have our contract table that we created from all of our activities. We can, since we know that those activities are sort of immutable, we can sort of generate this table every day from scratch, as opposed to like doing like an incremental join. Or we can also do kind of an incremental join if this is like an incremental table in dbt, right? You can do that if this is something that doesn't that does not change. Like this is, you can add data to it. Okay, so you'll see that from the customer ID, we created a customer table that has kind of the ID, the email, like a creation date, a cohort, which is basically calculated on top of the creation date, the first touch and the last touch channel in case that's needed by marketing. And we have a plan table that has the details and the features of a plan. You can also go from this design to kind of like facts and dimensions, and you like point the BI tool directly at this potential star schema and report from there. But you still have the activities as your source of business knowledge, right? The cool thing about having these activities is that first of all, they're ordered by time, so you kind of get like a customer 360 for free. But also, if somebody new joins the company, you can just show them this activity table and say, here's our entire business. Here's what happens when the customer first comes to the website. Here's how we know that they're interested. Here's when they fill out the form. Here's when they talk to sales for the first time. Here's when they get converted to a lead, and so on and so forth. So this also serves as a source of knowledge. So these models, right, like I said, they have multiple use cases. So we have the BI and reporting use case that I showed already. So you can use the metrics in a pre-aggregated cube like I have done. I've actually built that cube with dbt and DuckDB. DuckDB is kind of a newer in-process database for analytical reporting, similar to SQLite, but it's very, very fast when it comes to doing aggregations. You can create fact and dimension tables like a star schema, right? And you can have also data science use cases. So you can use this table as a feature store, right? So for data science, they kind of want to know these signals, right? So like recency and frequency are typically used signals in data science. So they will have fields like last time customer subscribed, last time that they churned, how far back in time did they first come to us? How old is this account? How often did they come to the website? How many times did they visit the particular page? And so on and so forth. So data science likes to have these kind of like signals or aggregated values, and you can build that table directly from the activity schema. You can also calculate a very important score in SaaS businesses, which is known as the customer lifetime value, either CLV or LTV. There's a lot of debate on how to calculate this. I'm not going to get into the details of that. I'll leave that to you for if you want to search on how this is done. There's plenty of articles online. But the reason this is important is because of these reverse ETL use cases, right? So you have your CLV and LTV calculated in your data warehouse for each customer, and you then want to send this to like a customer success platform. Let's say that you're using Zendesk or something, or Salesforce, right? And you want to know when somebody calls in with a question, right? You might want to filter them based on their lifetime value. If they are a very high LTV customer, maybe you show them the red carpet service. You send them to a much more senior customer service person who kind of knows the business or understands their particular use case. And if they're slightly lower, maybe they go to somebody else on the staff. So how does that work, right? How do you use this thing for more than BI? So with a tool like Census, you can take a query. Now this is not the actual query, but you can write a query on top of the activity stream or on top of your ERD tables, and map that data through census to any one of multiple of operational tools like you have here: Salesforce, HubSpot, Zendesk. I don't know if that's Google. That's probably not Google. But like, you can map this data to these systems since there's no native integration across these multiple platforms, and many businesses use a variety of these platforms, right? I've done this myself with CSV files. I used to create these extract jobs in SQL Server using a tool known as SSIS, right? I would write my query, build my table, and schedule that to refresh on a regular basis. And then I would have SSIS extract this table as a CSV and send the data over to Salesforce. Um, and once it gets incorporated in Salesforce, then someone on the sales team could actually see, okay, this customer actually visited the website on this day. They looked at this tour. This is what they were interested in. I was working for a travel company. So I've done this myself manually, right? In today's day and age where everything is in the cloud, right? You don't have to do that. You can use a reverse ETL tool like Census to kind of automate that for you. So how would this work, right? So you can see here, right? I have my query here on the left, and I send it over to Salesforce via Census. And what do I get? I get the LTV column added to my Salesforce case, right? So somebody that's uh, servicing this particular customer, they can see, oh, wait a minute, this customer's LTV is 200,000 plus. And maybe I have some kind of level that the data science team has determined, like platinum customer, silver customer, gold customer, et cetera, et cetera. And I can then divide this amongst my team given the training that they have received to either handle, like a platinum or gold customer versus like a silver customer, right? So this is something that is very, very useful, and you can get it from that activity stream. What does that actually look like? The activity stream, as you saw, right? It is a single table that has these 11 columns. This is the earlier version. They replaced this feature 123 with a feature JSON, as you saw. So it's very straightforward to map from source data to an activity stream for each of these activities. And then you can use this table to then build all of the tables that you saw me do, right? You can find some more information here on activityschema.com. And I just found out recently that someone has been working on a DBT package that takes this activity schema and kind of handles some of them, some of the temporal joints. So a lot of the way that you get value out of this schema is by using these temporal joints. You can read more about that on the activity schema website. I'm not going to get into the details, but this DBT package makes it super easy to generate those ER diagrams, right? And the idea here is like reuse, like model reuse. We want to use the same model that we created for multiple purposes. We don't want to create one-off custom tables every time that we want something, right? Every time that we want something new, we don't want to have to create a new table. And this kind of makes it very, very easy for somebody new to come in and say, okay, here's the tables that you need to worry about. Okay, and with that said, here are some resources. This is the book that I mentioned earlier. I've recommended this book before. It's pretty good. And then for those that want to go a little bit further, you can read about Kimball's dimensional modeling in his famous book, which is now a decade plus old, but the data still, the concepts still apply. A lot of people think that this doesn't apply anymore, because it's kind of outdated. And a lot of the ideas there were kind of designed in such a way that they would work on traditional databases. But now that we have these columnar data warehouses like Salesforce, BigQuery, etc., that is no longer necessary. But I think the concepts in there are very useful, especially fact and dimension tables. And for those that want to learn about Data Vault, these are the two books that I recommend. And that's it. Thank you very much. And we'll take some questions now.
Great, Ergest, thank you very much. We have had a few questions come in so far, and yeah, keep the questions coming. Ergest has got a plethora of knowledge, so he can answer a lot of these data modeling questions.
So how does this modeling process relate to Data Vault? Is it used instead of Data Vault, or do they work together? That is a good question. I don't have experience with Data Vault. There's plenty of people who do, and who think that the Data Vault is should be kind of that first layer, right? So in that particular sense, I think that with the method that I described based on activities would sort of replace the Data Vault. There's people that might disagree with me on that. Again, I don't have a lot of experience with Data Vault, so my take is that it would you would use that instead of the Data Vault. They wouldn't work together. You would have only one or the other. Okay, next question. Would the duration of a customer the duration that customer stays on a page count as an activity? No, the duration would be much more of a metadata, right? So you would have an event that says customer started session, and typically it's really hard to have like a customer completed session, because that's really hard in the world of web analytics. You don't know if somebody like left the page open, or if they closed the browser tab but not the actual browser, which everybody these days, or people just closed the browser altogether and moved on to a new page. So it's really hard to find that event that says customer left the session. But if you have the duration, you can add it into the feature JSON as metadata. Genesis. I know Genesis. We've spoken before. So what is your go-to for obtaining and playing around with practice data sets, or do you mostly look to create them yourself? Yeah, this is kind of the weakest link when it comes to data engineering, data science, analytics practice. There's not a lot of data sets that are kind of like represent the real world that you can play with, especially data sets that actually pertain to a company and their specific business model, right? A lot of these data sets that you find would be maybe government data sets, or data sets that are like a single table. So you never have that ability to like make tables that you join with each other. For my purpose, for the what I call it the metrics playbook, but then Abi calls it SOMA, which is like the standard. He'll beat me for this, but well, we're still working on the name. But for that specific project, I'm generating fake data that are just random. Okay, what do I think of data modeling with DBT? So I personally like DBT. I use it both professionally and for this project. The DBT is just a tool, right? DBT allows you to build this model both through activities and then turn activities into entities and attributes. So the reason that I like DBT is because you can have like a multi-stage transformation for data that is super messy. The way that I use it professionally, there's like multiple stages that the data needs to be transformed. But with something like an activity schema, one thing that I will mention with DBT is you want to try to have as few transformation stages as possible. And so that's why I'm talking about this idea of activities, right? Because people, the way that the way that they do modeling with DBT traditionally is by taking the source data as it comes from whatever, from Fivetran or whatever tool, and then transform that data by like parsing some strings, removing spaces, converting dates into actual date fields, and so on and so forth. That leads to a lot of that complexity that I mentioned earlier. So I recommend that you uh, go directly to from your source data to activities. You handle the transformations there, and then everything is kind of smooth sailing um, from there. Okay, question from Misha. Do you have any tips on how to go from basic facts and dims mess of a schema to the activities and entities efficiently? How to better sell this to management in your experience? That is a very good question. And I personally have not done like a transformation that goes from like a traditional messy schema to facts to activities. But one method that I've seen work kind of in general when it comes to engineering as an engineering principle is that if you have cycles, if you have a team, if you have spare cycles, or even if you don't have spare cycles in your team during a sprint, for example, you might want to allocate some time during each sprint to build this on the side. So while you support your live model, you build the stuff on the side, and you the beauty of having something like this already exist is that you can compare. Once you finish, some activities that comprise a particular dashboard or a particular report, you can run the two reports and you can compare and you can make sure that you got it right. So that is very useful, right? And then you can build and you can slowly transition people to this model. It is, I mean, in a large team, it can get pretty uh, hard. It can take time, but this is mostly a matter of policy, of having a manager who's empowered to kind of like carve up some time to make things simpler, and be able to like sell to management the idea that, hey, one, we can save on cost. So you have to keep in mind the fact that this modeling technique allows you to save on cost, and two, we're going to ensure that the numbers are going to be accurate, so people aren't just adding business logic on tables further and further downstream, or business logic that exists in the BI tool. If you have business logic in the BI tool, that to me is a no-no. Like if your Tableau or your Looker has business logic baked in, you are stuck with that vendor. If in the future you want to move to another vendor, it's going to be a very heavy lift. All right, next question. Would Yeah, would from Mukunda, would you suggest this modeling pattern for activity event type of data or for all type of source data? The team that came up with this, they built a tool called Narrator, narratordata.com. They claim that you can use this for pretty much everything. So this would cover a wide range of use cases. So I believe it can be used. I personally haven't seen it used, and in my professional uh, capacity right now, I'm building like much more of a traditional ER schema, but I am building this for my side project, which is going to be free, by the way. So I can plug in a link if you just go to GitHub and search for my name, like Ergest, as opposed to Ergest X. You'll find it's called Metrics Playbook. So I would suggest this for as many of these activities as you can. Again, the idea is that you model the way the business works. If somebody were to do a select star from this table and pick a customer, they should be able to see, when was the first time the customer visited your website? When did they convert to a lead? When did sales contact them? When did they open? When did they sign up for? When did they sign their contract? When did they start their subscription? And then you can take these activities and you can kind of like through temporal joins, you can join them in time and you can build like a causal sort of model, if you like, that you want to say, okay, how many people visit our website before they open a ticket? Or how many people go to the FAQ page before they open a ticket? And if you see that most people aren't even going to the FAQ page before they open a support ticket, well, maybe you want to make that page more visible to the homepage. So that's the beauty of having these activities be both immutable, but also be able to kind of join in time through customer ID and timestamp. Okay, Parker, I believe the question from Misha was already answered. So next question from Ryan Murphy. What is the limit of the JSON column? I have a few hundred columns of metadata that end users can ask for. Okay, when is there too much on the JSON column? Can it degrade performance? So modern databases, modern data warehouses do very, very well with text and compression. So they can compress things very well. That said, there's an alternative thing that you can do is that you can actually store a foreign key, if you will, because the constraints are not maintained in data warehouses. So you can store the key to a dimensional table, and then whenever you join that activity to the dimension, like for example, let's say that you have a page, like a page table that has all the attributes of that page, the page type, the UTM campaign, et cetera, all this stuff. Maybe don't store that in a feature JSON because that could get very unwieldy. In fact, if you look back at the original spec, they only had 3 columns. Right? They were like, you can cover 80% of use cases with 3 columns. Now, if you wanted additional metadata, you could create, if you go to the webpage, activityschema.com, you can then create a separate table. They call it an enrichment table. Right? So that's also an option that could be supported. Okay, next question. The customer dimension data might change. Wouldn't you need to do that as an SCD? So an SCD, for those who don't know, is a slowly changing dimension. And that means that a customer might change their email address, or they might change their name, or a lot of these dimensional type of information. Yes, you would have to do something similar to a slowly changing dimension, but by having these activities be immutable, right? You can store exactly what the name was at the time when the activity occurred. And then on their website, Narrator recommends that you can have kind of like as an SCD activity. Like you can actually say customer updates their name and old name, new name. I haven't done this myself. I've only read about it on their blog. So if you search for Narrator SCD, slowly changing dimension, you'll see basically how their approach works. But don't have personal experience with that. Question from Joshua. Hello, Joshua. I think Joshua is calling in from Africa, if I'm not mistaken. So is the recommended modeling pattern similar to DBT's staging intermediate layer? That's just a way of organizing data, right? Staging, and then you have, I think, like they have staging and live, or silver, bronze, silver, gold. There's a lot of these. These are mostly the ways of organizing data in your data warehouse. Like you don't have to follow them strictly. If a company follows them because it's part of their policy, then sure. I mean, if you get hired by them, you'll have to follow their patterns, but it's not something that's set in stone. Question from Ella. You mentioned that JSON should be used to add extra features rather than creating a new column. When do you deviate from adding it to JSON? I think I understand what this is getting at. So the idea is you wouldn't modify an existing event, right? So you would store whatever information is necessary. Uh, the way that Narrator has done their modeling with the three features is that they can build kind of a dimensional table by stacking together, by joining together these activities in time, by saying, give me the first time that the customer visited the web page, and then the first time that they visited, the first time that they submitted the form, and then the first time that they became a lead. And you can join all these together through the timestamp, and then take their features and turn it into like a dimensional table. Uh, I've only worked with like the newer version, which is the JSON column, but I mean, feel free to deviate from this model, right? This is, again, this is not set in stone. This is a model that they found very useful. I found very useful for modeling business specific activities. Do I think facts and dimension tables will be necessary in the future? They feel archaic. Question from Harrison. Um, That's a good question, right? The trouble with that is that a lot of these BI vendors, whether it's Power BI, whether it's Looker, Tableau, I don't, et cetera, Superset, and so on and so forth, they were all designed with a star schema in mind. The reason for that is because it's very easy to aggregate data on a star schema. It's super easy to say select count from table where group by such and such dimension, and so on and so forth. So it's very intuitive for somebody who doesn't really understand how to join tables. So they might feel archaic because Kimball wrote about them back in the 90s, right? But logically, a schema that has like a key, and then it has some kind of metric, and then some kind of date, it's a very natural schema for doing things like aggregations, ratios, all this type of stuff. So I don't necessarily think it's that archaic. I think it's, according to Kimball, by the way, if you read the book, he says that this is a very natural model. People naturally think like this. They think in terms of dimensions and measures. Oh, I want sales by region, but then I also want them by by rep, and region, by country, by state. So it's like very natural for people to think like this if they're looking for just pure reporting. Tim, hello, Tim. Tim is a good friend of mine from Twitter, and he has helped me out on numerous occasions with some Unix scripting. So, when dealing with large fact and event tables, do you recommend indexing techniques? Well, these work best in columnar databases, not in traditional um, databases. In fact, if you read this website, the creators say that, hey, this only works for modern databases because you can use partitioning by date and time, and you can do the queries can be very fast because there could be pruning where data that's not looked at can be automatically discarded. So this modeling technique doesn't work if you're using Postgres or SQL Server or MySQL for your data warehouse. But if you're using BigQuery, Snowflake, DuckDB, God forbid you're using Redshift, then you can use this.
Okay. Thank you everybody for attending. This event was brought to you by the Operational Analytics Club. And Ergest, thank you so much for doing event number 3 with us. We really appreciate it. And anytime you want to come back and teach us, we are here for it. And if you aren't a member of the Operational Analytics Club, I'm adding a link to the top of the screen. And that's how you can join. And also, like I said at the beginning of this call, this event was recorded, so you will receive a recording later this afternoon. And if you have any more questions for Ergest around data modeling, SQL, or one of his other many data skill sets, you can find him in the Operational Analytics Club.
Yep.
And with that, everybody enjoy the rest of your day, enjoy the rest of your evening, and we hope to see you at another event soon. Thanks, Ergest.
Take care.